Alright, so this is video number 3 on programming our Gyrocam. On the last video, we did communications to the phone from the unit using an HM11, and you can see we started getting into problems when we lower the timeout to, I think it was 2 milliseconds or so. So this is not efficient. That's not going to work, right? So we need a better way of doing this. And the way we do that is we want to enable global interrupts for serial communication. So you go to UART port 2 NVIC settings, and we enable the global interrupt. We're going to generate a code. Okay, now that we have the code for doing interrupts, we need to create two variables and one function to make this work. So the first variable is going to be a flag that is going to tell us if we're able to send. So can we transmit? So when it says transmit ready, that means that we can send more data. And the next one is a buffer. It's going to be 50 characters in length. We'll also need a function, so we're going to do the prototype here. We're going to call it log. It takes a pointer to an array of characters, and it takes any number of parameters after that. And here's where we define the log function. And we check if we can send data. So if it's 1, we're not busy sending data. So we want to set it to 0 to tell the system now we're busy sending data. We also need to declare a variable for those arguments, the arguments that are going to come here. I forgot this. Right, so we're going to store whatever we add to this location of memory into this variable here. So we say start, we give it the arguments, and we put the data. So we're saying the variable list, or I don't know if that's what it means, but in any case, we're going to store whatever came here in that header in here, and this data starts after this parameter. Then we're going to save that into our buffer, and we put data plus whatever came in arguments. We end it, and then we send it. This time, instead of using this regular transmit, we're going to use the second one. So this one takes one less parameter. It only takes the pointer to serial communication, the data we're sending, which we're putting it in buffer, and the size. Right? So easy function to understand, right? We're checking to see if this is 1, that means we can send data, and then we flag it as 0, so that if this function gets called again, it'll say I'm busy. It'll be 0, so it's not equals to 1. So it'll skip this saying I'm busy sending data, so don't bother me. And then it exits. That's all it does. This function here, it does not take a timeout like the previous one, because it just loads the data for sending, and it lets the background process do the sending for us. And when it's done, it's going to call another function where we are going to set this flag to 1. So let's go get that function. It's under drivers, hardware drivers, source, UART, and we search for double underscore week, and we're looking for this callback. So the txt, I'm gonna if that's complete callback. I know there's this one's half duplex. So we copy this, we bring it to main C. We're gonna put it below this one. We need to remove weak, remove all of this, and in here we put rating equals 1. So when we send data, this is going to return it immediately, and when it's done sending the data, the background process, when it's done sending the data, is going to fire an interrupt, and it's going to call this function where we specify a flag to 1, stating that we can send more data. So now we can call this as many times as we want without concern if it's going to be sent or if it's going to create a bottleneck in our system. So if we go by what we did before, we don't need the buffer anymore, and we just need to say log that, right? Because this one does all the heavy lifting for me, for us, I should say. So I'm gonna run it, and you're gonna see this just shoot up really fast. The numbers are gonna go into the millions really quickly, and then I'm gonna explain what's happening. So you can see, you can see what is just. Well, let's run it, and we'll see. Okay, we have an error. So the error here is that it doesn't know what this is, and we need to include a header. So let's include, and this one is called arguments H. So that should be it. Let's compile it. Let's make sure everything works correctly. We have no errors. Let's download it. Right, so there's your data coming across. You can see this number shooting up. That's in the millions, 6 million, 7 million, 8 million. But this number is pretty small, right? So what's happening here is it's telling you the data is coming to the phone as fast as it possibly can, but this number doesn't match the number of lines we have received. So what's happening in the code, it's what it's telling us is that this line is executing that many times, or has executed that many times, and data has only come across whenever this thing is set to 1. So it'll get called every time it goes through the loop. If it's set to 1, then it'll load the next set of data to be sent. And if it's not set to 1, it'll just bypass it and come back. So it's not sending all this data, but it will not creating a bottleneck. Sending the data is not critical because we will always be sending the latest data. So if it doesn't go through on the next loop, it'll go through and it'll be the latest data. So we don't care if it gets sent or if it doesn't. We want to keep our loop running as fast as possible. So that's how you send data really fast, or how you send data using global interrupts without creating any bottlenecks in your code. And just a quick explanation again. I went to USART2, went to NVIC, enable global interrupts. In the code itself, I went and created 2 variables, one to tell me when I can send data, and another one to the data that I'm going to send. This has to be global because this is used to send data on the background, so this needs to be accessible to that background process. But I don't know if it's a background or not, but it needs to be global. Then we created our log function that takes an array of strings, an array of characters, and then any number of parameters after that. So this becomes essentially the formatting of this data you're going to have here. And the function, we check to see if the data is ready. I mean, if we can send data. If it is, we block it. We define our holder for our arguments, from these arguments, and then we tell it where it starts. It starts after this, right? After that one. Then we get whatever arguments we got. We use the format we got in this variable, and we store it in tx buffer. and then we say we're done with it. We send the data, and then we also got this function, this callback from the UART.c file, and this is where we change where we set the flag to 1. We also remove the weak, I don't know what that's called, but we want to make it strong because this is going to be the function. We don't want it to, if we leave it weak, it may end up going to the actual function in C instead of here. So that's it, right? We also went and specified that the processor was running at 64 megahertz. So that's it. On the next video, we'll do two-way communications. So we're going to have communications coming from the phone to the unit, and then we'll send it right back to the phone. So just so we can see that we get data back and forth. See you in the next video. Enjoy.